Hey, what's up guys? Welcome back to Austin's magical land of tutorials. Yeah! Okie dokie. So today, what we're gonna be doing is taking a look at the ModelSim software that was included with the download of the Quartus Lite edition. So what we're gonna do first is go ahead and open up the program, click. And essentially what we're going to be doing is with ModelSim, well, what we did with Quartus is that we created a design, whether it be a schematic design or a VHDL file, a text design. And what ModelSim does is that it generates a waveform diagram that verifies the functionality of the design that we created using Quartus. So the first thing we're going to want to do when we open up ModelSim is we're going to go over to File, go over to New, and go to Project. And this is exactly what we would be doing in Quartus as well. We just create a new project. So we're going to create a project name, and I'm going to do Helicity tutorial sim, and then we can pick a project location, so where we want whatever directory we want to save our project in, and I'm just going to keep it in the Intel FPGA Lite directory. And then it's going to allow us to choose the name of our library that we want to save the files that we want included in the simulation. And I'm just going to leave that as being called work. So I'm going to click OK. And so now we have the opportunity to add files to the project. And we can go to Add Existing Files, Browse. And so this is where we would add all the files that that are required for the Helicity project. So the files that we were sent by Ed. So I've saved all my files here, and we're going to include all of these files. And the file that we left out last time, which is the Helicity Fit TB file, this is our test bench file. And this is actually the most important file for ModelSim here, because this is the file that we're going to use as the basis of our simulation. So I'm going to go ahead and select all of these. And I know there's a faster way of selecting files, but I have forgotten how to do it, so I'm going to do it the long way here. And I'll click Open. And click OK. Alright, yippee. We got some files. So we can see all of our files, all the files we want to include pop up here in the Project tab. And something we should take notice of right away is in the status column, we have all these blue check marks. Wow, I wonder what those mean. Well, I'll tell you what those mean. So essentially, because we just added these files to the project, we haven't yet compiled them in ModelSim, so we need to recompile them. So we're going to go up to Compile and Compile All. We could do Compile Selected if we selected all the files, or if we only had a couple of files in here that we wanted to compile right now. But we just want to do all of them, so we can click Compile All, and we can check the status here in the transcript. And if we look back up in the status column, we see these green check marks, which means that all the files were compiled successfully. So actually the next step is to go ahead and start the simulation. So the way we do that is go up to Simulate, go to Start Simulation, and we find the library name where we stored all of our files, which is work. We're going to open that up. And the file that we want to use for the basis of the simulation is Helicity Fit. So we click OK. And a couple new tabs are going to open up for us to use. And so we have the Objects tab that's popped up. This one's very important. And we also have the Waveform tab. And so the Objects tab is a list of all the inputs and outputs from our test bench file. So we want to take the inputs and the outputs from here and place them in the Waveform tab to see if they're working appropriately, and we'll model them. So the only input we have actually in this particular file is the clock, and it's a 20 megahertz clock. And the way we add it to the waveform simulator is we can simply click and drag it like so, or we can right click and go add wave. So we can go ahead and just test to see that things are working appropriately, and and that our input is what we expect it to be. And a quick way to do that is to go ahead and just run a simulation. So we expect to be a 20 megahertz clock, and I'm just going to go up here and I'm going to edit our run length to be 10 microseconds. And what the run length does is when I press the run button, which is right here, it's going to run the signal for a period of time of 10 seconds, 10 microseconds. And so I'll go ahead and click run. And this looks kind of strange, but it's probably because our zooming is wrong. So we can go right here and we can go to zoom full so we can see the full waveform. And now we have something, but it's very small in the window that we have defined here. So we can go ahead and click zoom in, and we can start seeing our signal. And if we zoom in enough, we can tell. I'm going to move the cursor back to the front, to the start point, and I can move the cursor over. So if we look here, our window is our scale here is 50 nanoseconds, and we can see that the period does repeat in the 50 nanosecond window, which is exactly what we'd expect from a 20 megahertz signal. So it looks like our clock is working correctly. So now we can add a few other signals that are pretty important to see if they're working right as well. And some of those important signals are the T-settle and the T-stable. And what the T-settle and the T-stable signals do is that when we're choosing the next Helicity state, the T-settle signal is being triggered, and the T-stable is triggered once that Helicity state is chosen or stable. So something to be aware of is that these are complementary signals and that they should be opposite one another. And so we'll see if we see that. So we can go ahead and click run again if we want, and our signal will pop up. But I kind of like to go ahead and restart so I can see the signal from the beginning, instead of, if I drag this cursor back here, we see that the signal doesn't last the entire time we've been running the program, just after the last 10 microseconds. So I can go back and I can go to simulate, and I go to restart and click OK, and it restarts. So I'm going to go ahead and click run, and I'm going to click run again and run one more time, and I'm going to go zoom full. It looks like we got something going on here, so I'm going to click run again, run again, run again, run again, and I'm going to zoom out and click run, and we see our signal coming up here. And I'm going to click zoom in one time, and this is exactly what we expect from the T-settle and T-stable signals. They're equal and opposite. So when one is high, one is low. Okay. And a few other signals that might be useful to look at are the Helicity state and also the pattern sync. And so I can go ahead and drop the pattern sync in, and I'm going to drop the Helicity state in as well. And like I said, I like to restart from the beginning. So I'm going to click restart. And I'm going to start running. So now we got some stuff going on. Well, if we look here, I've toggled the mode of the Helicity signal to be in quartet mode. So what that means is that in each window of the pattern sync, which is the signal that records when it's the period in which our pattern for the Helicity is set. There's going to be four Helicity states included there, and so every time we have Helicity, we have T stable and T settle triggered is when we're either looking for a new state or a state has been set. So a state has been set here, a state has been set here, a state has been set here, a state has been set here. And so we can look here at Helicity state, and that we see that we have a plus, we have a minus, we have a plus. Oh, I'm sorry. We have a plus, a minus, and a plus. And that's included here in the window defined by the pattern sync and the T stable and T settle. So this is our window. So it looks like things are working well, and like I said, we're looking for a quartet, and that's exactly what we have. In the next video, I'll show you how we can edit the source file for Helicity Fit so that we can switch between the pair, quartet, octet, and toggle modes for the Helicity signal. Okay, thanks a lot.